So in this video, I will be studying a problem in which we are given the Rutherford model of the hydrogen atom, where we consider that we have a proton of mass capital M, charge capital Q, representing our nucleus, and an electron of mass small m, charge small q, moving around the proton in a circle of radius 0.1 nanometers. We're given K is the Coulomb force constant, which is 1 over 4 pi epsilon 0, and G is the universal gravitational constant. The question is to find the ratio of the electrostatic force to the gravitational force between the electron and the proton, and then we want to find the velocity of the electron so that it rotates around the proton with a constant speed. So to solve this question, I will first just give you an overview of the formulas that we will be using. So to compare the electric force and the gravitational force between the electron and the proton, we will need to know the formula for the universal law of gravity, which is basically a law that gives us the force of gravity between any two objects. In that case, we are studying any two objects of any mass, and we want to see the gravity between them. Why do we have gravity between them? Well, the general formula which we know for the gravity, which is basically the gravitational force exerted by Earth on objects that are on its surface, this formula, it works for the gravitational force between Earth and objects that are on or near the surface of Earth. But if we are studying objects that are not really close to the surface of Earth, then we will have to study the universal law of gravity. Also, so for example, that would be Moon and Earth obey the universal law of gravity, not Fg equals mg. And also the universal law of gravity can be also used to study the gravitational force between other massive objects such as the Sun and Earth, or the Sun and Jupiter, or any two stars, or actually any two objects, whatever their mass is and whatever objects they are. So actually the universal law So if I'm studying Jupiter and the Sun, I can find the universal law of gravity between the Sun and Jupiter. Or I might be studying the force of gravity between Moon and Earth, as we discussed earlier. And the objects do not have to be even space objects. I might be studying the universal law of gravity between me and the Moon, although it will not be a significant force because obviously I'm not feeling any gravity towards the Moon. And it can even be between an electron and a proton, but again, we expect that to be very small as well. And the question actually which we are trying to solve asks us to find or compare the electric force between the electron and proton in the Rutherford model to the gravitational force between the electron and the proton. And yes, I do expect then to have a very small gravitational force. Why? Because if you look at the formula for the universal law of gravity, you can see that for any two objects of masses m1 and m2 separated by a distance r, the force of gravity between these two objects is equal to a constant g, which is the gravitational constant, times the mass of object 1, the mass of object 2, over the square of the distance between these two objects. So this is basically the formula we use to find the force of gravity between any two objects of mass m1 and m2. So this can be applied everywhere, whether it's between planets, between stars, between galaxies, or even between an electron and a proton. But as you can see, this force for very small objects, it will be quite weak, because g itself is of the order of 10 power minus 11. You can see this here. And this will weaken the force a lot. But for very massive objects such as Earth, this force can become significant again. That's why we feel the gravity of Earth. It's significant, and the gravity of Earth is actually what keeps all objects on its surface. So basically we can use this formula to find the gravitational force between the proton and the electron in the Rutherford model. So this will be g times the mass of the electron times the mass of the proton over the separation between them squared. This is Fg. Now our question is to find the electric force ratio to the gravitational force. To study the electric force, I remind you we're just going to use Coulomb's law. Coulomb's law tells us that the force of attraction or repulsion between two charged objects is given by the formula that we have here. We are given that the electric force is equal to the constant K, which is an electric constant, times the charge of the first object times the charge of the second object divided by the separation between them squared. Remember, K is equal to 9 times 10 power 9. Q1 and Q2 are magnitudes or absolute value. So even if the charge is negative, Q1 and Q2 have to be written as positive values. They're written only in terms of their magnitudes. The force is an attractive force if our two objects have opposite charges. So I have here a negative charge and a positive charge, so the force between them is attractive, whereas like charges will have a repulsive force between them, as you can see here. So going back to our question then, I can write down the formula for the electric force. This will be K, Q of the electron, Q of the proton, over the separation between them squared. These will be in absolute values, so I will keep them in absolute because, as we said, they have to be magnitudes. So solving for the ratio, this gives me r squared and r squared actually cancel out from both formulas. I will have K, QE, Q of the proton, divided by G, mass of the electron, mass of the proton. And we can actually solve for this because everything here we know it. We can just substitute K by 9 times 10 power 9. The charges of the electrons and the protons are the same. It's 1.6 times 10 power minus 19 coulombs. They have opposite signs, but I will substitute everything here in positive values as we said earlier. And in the denominator I have the constant G, which we have just written its value here, 6.67 times 10 power minus 11. The mass of an electron is 9.11 times 10 power minus 31, and the mass of a proton is 1.67 times 10 power minus 27 kilograms. So basically I can directly calculate the value of this ratio. The answer will be 2.4 times 10 power 39, and we have no unit here because we're studying the ratio of the two forces. So this will be Newton over Newton. The ratio will have no unit. Now in part B, they ask us to find the velocity of the electron so that it rotates around the proton with a constant speed. What do we mean by a constant speed? Then, okay, we can see that the electron is moving in a circular path, so the speed is this tangent. However, if we have a constant speed, then this means we are in uniformly circular motion. So I can say here, constant speed implies uniformly circular motion, which we know from mechanics, it indicates that our acceleration is centripetal and is equal to v squared over r. How will this help us? Question is to find v. Well, we know the forces acting on the electron. We have an electric force and the gravitational force with the proton. Well, F net, which is ma, can be written as m v squared over r. This tells us that v, if we rearrange our equation, will be equal to F net times r over m with a radical. Now, if we look at our forces, we have seen before that the electric force ratio to the gravitational force showed us that Fe is much bigger than the gravitational force. This means that actually this can be considered negligible, and then F net can be written as the electric force only. So actually we can now substitute F net by the electric force only, which is KQE, Q of the proton, over r squared, times r again over m. Of course here m is for the electron, so the rest is actually just some substitution. We will get here, if we substitute our values, 9 times 10 power 9, then QE and QP is the same, so I'll have 1.6 times 10 power minus 19 squared over, you can see how r here cancels with r squared. So I will have in the denominator the mass of the electron, which is 9.11 times 10 power minus 31, times the radius, which was given to be 0.1 nanometer in our question here. So you can see that we're given this as our radius of the circular path taken by the electron. So I'll just write this down and I will change it to meters. Basically, we can just calculate the velocity. We will obtain a velocity of 1.6 times 10 power 6 meters per second. So we're basically able to find the velocity of the electron using the principles of uniformly circular motion and neglecting the gravitational force between the electron and the proton, which makes sense for very tiny particles as these.